Here we want to solve log base 2 of x minus 5 equals 3 for x. When we have a log on one side and a number on the other side, the key here is to convert this to exponential form. And by that I mean you start with your 2. 2 is still the base in your exponential form. You go around to the outside like this. This is your exponent. And then back around to the inside. This is your equals. Okay, it goes around like that very nicely. So what this gives us is 2 to the 3 back around for the equals x minus 5. Right, this is exponential form. Exponential form. Let's solve this equation. We get 8 equals x minus 5, and then adding 5 to both sides gives x equals 13. Now, anytime you're solving logarithmic equations, you must check your answers. Okay, must check the answers with logarithmic equations. Okay, because they will give extraneous solutions. And you don't have to check them all the way through. You just make sure that you're not putting a negative into the logarithm. Okay, so make sure not putting a negative into a logarithm. That's not very mathematical, but that's the simplest way of putting it. Why do we care about not putting a negative into a logarithm? Well, remember the graph of a generic logarithmic function, right? It goes like this, something like this. So notice that the graph, there is no way to put a negative into the log. The domain of this thing, right, is 0 to infinity. So we can't put negative values into logs because negatives aren't in the domain of logs. So if we got an answer, like say we got x equals 1 for this answer, right? If we got x equals 1, then we plug that in, we get 1 minus 5, which is negative 4, and then we try to take log base 2 of negative 4. So that answer would have to get thrown out. Luckily for us, we got x equals 13. 13 minus 5 is 8. That is still positive, so this answer works. Right? And so you want to make sure you check that for every single one of these logarithmic equations. Make sure your answer doesn't force you to put a negative into log.